So really, the less than, I can write like this because it's going to end up being this. I want you to stay close to me, like this. So that's why I'm able to write it like that. That's beautiful. The greater than, I can't do that because it's going to be like this. It's going to be separate things. Either over there or over there. Just don't be in here with me. Just stay away, right? So I have to write the two cases. These are exact same two cases we were doing before. It's just that that guy's got to switch. Why? Because there's a negative involved. And then you just solve each of those. Plus, why does this make sense? Remember what we said. What number do I put in there to make it work if it's a negative number? I can't use something less than negative 7. I have to use something, greater than negative 7. I have to use something less than negative 7 to make it work. I mean, negative 8, negative 9, so forth. So you can just see that it's got to be this way. You can just see that it's got to be this way. So now you solve both of those. That's the easy step now. Subtract 5, divide by 2. Subtract 5, divide by 2. I didn't divide by a negative, right? It's only if you divide by a negative. So what would I divide by here? I divide by 2, so the sign does not switch. Don't switch the sign just because there's a negative somewhere.
What if it was negative 2x? The sign
Then you would switch it because you have to divide by negative. I like it. It has to do with what you do, not with what's there. All right? I didn't divide by negative, so the sign doesn't switch. How do I graph this? Well, it's got to be greater than 1. Or, hey, there's that stay the hell away from me idea, right? Here's me. Stay the hell away from me, right? And how do I write this in interval notation? Yeah, negative infinity up to? I got to stop here. I don't want to include any of this stuff. Or 1. Yeah, I always think about this one as a skip. What do I skip? What numbers do I skip? Everything between negative 6 and 1. I skip between negative 6 and 1. I really want you guys to realize, if that would have been a less than, the answer would have been here. Negative 6 to 1. So greater than is the opposite of what it would be. It's out.
That's the concept of 8.2.
That's it.
That's it.
Yeah.
Okay, that's it. That's it.
So it's the absolute value equations
Okay.
and the inequalities. Equations are beautiful. You just got the two cases to do. Inequalities, always a little harder. Just is. You got to remember that less than, stay close. Greater than, stay the hell away from it. Yes?
So if you looked at that problem on the right, since you already see that it's like it's gonna be less than 7, would you just automatically know that it's gonna you do all of that, but then on the other thing you change the signs or something?
Yeah, so here, let me show you. Here's what's really going on. All right. So if I have this problem, what's the absolute value of something that we don't know? It's either itself or it's the opposite of itself. Stay with me now. That's remember, what's the absolute value of x? It's x or negative x. So you guys are looking at it like, wait, you didn't switch the sign. Because what could I do here? I could divide both sides by negative 1. And then what would I have to do? So I like to start here. Either that is greater than 7 or that is less than negative 7. So you change the sign on the second case. Yes?
The key is got to make sure to flip the
Exactly. Now, to be honest, on a problem like this, all right, this is kind of dorky. I don't give a shit. Either x plus 1 is 7 or x plus 1 is negative 7. I switch the sign. Sorry. But of course, when you flip an equal sign, it still looks like a freaking equal sign, right?
Mm-hmm.
Here, switching the sign is going to actually make it look different. So I like to start here. So greater than, stay away from me. You're going to have one case or the other case. Less than, stay close to me. You can always rewrite it. Let's have a little lightning round here. So let me get us started. Like, how would I rewrite this? I rewrite it as -2 less equal to x plus 1 less equal to 2. So how would you rewrite? Yeah.
Less than 4x minus 5 less than 11.
Yeah. Either 4x minus 5 is less than 11, or 4x minus 5 is greater than -11, if you read it that way. So I can just put it all in one line. It's a sandwich. It wants to be close. I should be able to write the algebra as a sandwich. Jelly and bread. Yes?
The absolute values that you're looking for to be less than, that's not the other.
Yes, this whole thing is less than 11. Then I can rewrite it like this.
Okay.
I like it. But if I had...
Eight x plus 5 is less than -2,
Okay. Or?
or 8x plus 5 is greater than 2.
So one case is always leave everything the same. Because if that number is already bigger than 2, of course the absolute value is going to be bigger than 2. Or if it's big enough negative, it's got to be big negative for the absolute value to end up being bigger than 2. That's why it's got to be less than -2, like we thought about earlier.
No, I reason I did that because it makes me see a visual relation. That's why I did the negative.
Oh, I see. Yeah, no, this is the negative, here, the negative and then the positive. I like it. I like it. Okay, so let's do this. Let's take a break. I'll let you absorb what we've talked about. I'm going to go print out hand out this practice for this. What? Come back at 9:30?
Jeff, I had a question.
Yeah.
Why do you do this?
Oh, I used to always say